Well, g'day guys, welcome to the channel. Now, this little fella, our national, one of Carl's radios, and it's a restore job. So, I think it's about time we got back onto it. I did the intro for you, that's the last video on it, and we sort of had a bit of an overview of it. It's a battery set, it's battery portable, so we're looking at 90 volts and 1.5 volts for the filaments. So it's a standard arrangement as far as that's concerned. We've got a circuit, so we rounded up a circuit, which the lights are fairly bright there. But we'll get to this in a minute. What it is now there was a bit of uncertainty as to what the battery system was in it, because I looked at these and thought, oh, okay, there's 3 pins and they go across here and they're parallel. Well, no, they're not. They're let's put that straight. They're in series. Okay, so it's a 45 volt and a 45 volt, which is your 90, and this little 2-pin fella is your 1.5 volt, which I don't know what it is. They may have been C's, may have been D's. I think C batteries would be, just looking at where it's fitting, I think it'd be C batteries. So I'll give you a bit closer look at this. There you go. There's the battery arrangement, and as you can see, our HT is about 83.5 volts, and our 1.5 volt, well, yeah, is just for the filaments. Okay, so our IF is 460 on this one, and the all important, that's what it is. Okay, so I've got this. I've printed off the circuit. Actually, quite a bit of information. There's alignment details down here. There's a parts list down here, which is, yeah, very good. And well, there's the radio, as we've already seen. So I don't know whether it's going to look like that when I'm finished. That was actually one Carl had sent me, and was a 5B circuit, but strange, because the radio is basically that radio, but the 5B is not quite the circuit for this one. Very, very similar, different valves. So there's our valve lineup as I've taken you through it. A 1T4, a 1R5, another 1T4, 1S5, and a 3Q4, but it's actually got a 3V4 in this one. Okay, enough of the formalities. Let's get on to this. I've got to do something with this dial to preserve it straight off. So, yeah, it's remove this, sticky tape along the top. It's a paper dial. It'll probably clean up okay and everything will look okay, but I want to somehow remove it from here so it doesn't get damaged any further with us, throwing it around a bit. Well, not throwing, probably the wrong word to use, seeing it's not my radio. Okay, let's get into it. Well, here we go. Now, I'm also going to start this up and see if we got any activity or anything like that. For a start, our dial. Sticky tape doesn't take much getting off, but this may. Just having a look at how this is put on. And yes, the front panel is all one piece. Don't really want to take the dial cord off if we can get away with it. Just gradually. There we go. Don't know what that's been put on with, but yeah, this will clean up okay. probably say probably between two sheets of glass, or I was going to iron it to get it straight, but we got this rubbish on the back of it. I will certainly scan this, and so we've got a full-size copy of it before we sort of go any further with the dial. So at least it can and possibly will be recreated. There's our pointer, and lots of black, don't know what, on there. Yeah. Okay. Now, for a start, to make the radio accessible, it'll be remove the speaker. And, okay, I do see something here on the speaker. That's a little bit of a worry. Okay, let's bring our light down a little bit and have a look in the center of the speaker. We seem to have a nut in there. It's a bit of a worry, isn't it? Okay, well, hopefully that's all that's gone in. Okay. I'm not sure. A very, very strong magnet on this speaker. It probably will need a new piece of felt there. Speaker feels okay now, so I noticed it rubbing when I first tried it, but I didn't actually see that nut. So, okay, let's remove the speaker and have an overall look at things before we connect anything up. Okay, so we're looking at, I should be using my turntable, shouldn't I? 4 screws. The front comes off this, hopefully. Okay, let's get her out. Okay, we should be able to get the speaker away from the front, I think. No. What's holding the speaker in? Nothing, only this piece of gear here. There we go. There we go. Oh, gee, that magnet's strong on that speaker. And I wouldn't think they'd be original speaker leads. There she is. It's a Roller 8M. Okay, so 8-inch. And I don't know how many ohm this thing is. It's got 408. It's probably 15 or something. I don't know. This plate doesn't look original either, but it must be. It just looks, well, not homemade-ish, but just doesn't look like it should. Right. Under here, now, first of all, before we go any further, I'm disconnecting the speaker. And I don't know whether we've got positive and negative on here or one of these. They don't look like they're grounded onto the speaker basket. But of course, you never know. I was caught out a couple of videos ago with that. Right. Speaker's out. We'll take him off the cover and then we'll inspect him a little bit later on. We can use an external speaker on this one. Okay, here we go. And as you see, the wax is here. There's a replacement here. A 47,000 picofarad. Probably the 3v4, probably would be a grid coupling from the IF transformer there across to the screen of the 3v4. Waxy, and of course a few associated resistors. We've got a 1 meg there, 100k there, 1 meg, a 50k there, no, 500k there, a 1 meg there. So yeah, it'll be interesting, won't it, guys? Okay, now this is probably our on-off switch, as I remember. First of all, do we have continuity of our valves? Let's have a look. I'll keep you in the picture there. This is pretty exciting, this old girl. Okay. Let's see if we got anything across our filament line. No, we don't. Okay, there. And yes, we do. We've got 3 ohms. Okay, we've got all these are paralleled, so that's turned on. But whether or not each one is lighting up, well, the pins. What are the pins? 1 and 7. 1 and 7 on all of them. Okay. Rather than guesswork, let's have a look at each valve. So we'll start here. Should have started. That's the 3v4. We'll start at the 1T4. And let's have a look. Yes, he's okay. If I can get a good connection. 9 ohms. Yep. We're right for that fella. Okay, next one. In here is our 1S5. Yep, 10 ohms. We're right. So far, so good. The hardest bit's getting them to sit back in. Okay. Now, this little fella, this is our 3v4. So the 3v4 is, yes, it's still the same, 1 and 7 with the center tap at 1. And we've got continuity there, 22 ohms. And the other one is where? I can't read that on the, but anyway. It looks like 6, but it's not. It must be a 5. There it is there. Okay, 5 and 7. And 5 is, 1's the center tap. So there it is across there. So all good on the 3v4. Okay, we'll move along up here. And this is our lucky last, 1R5. And yes, he's okay. If I can just get a connection. Yep, 9.5. Also has a slight bit of corrosion. It might be paint, actually. Something. Don't think it's corrosion. Anyway, all the valves are correct. 1.5 volts. There we go. And we're going to, at 10 ohms each, we're probably looking current draw in around 200 mil. So we'll limit our current to 220. Okay, so that's the current limit at 1.5. Right, now what I'm going to do, first of all, we know that's turned on. I'm going to put the power supply on the filaments to start with and see, have we got current draw? Is it about normal? Okay, I'll just grab my gear. Okay guys, well, here's our power supply leads on here. Let's check our current consumption. Now over here, we've got 220 milliamps on the current trip at 1.5 volts. Okay, so what do we go here? Plus and minus, and I'll turn the supply on and see how much we draw. Okay, on one there, I'm just double checking. Here we go. We're drawing 219 milliamps, which is about right. But the voltage has dropped a little bit. So let's take this fella up to 250 milliamps, 260 maybe. And what are we drawing? Okay, 252. Spot on. Valves are working. Okay, let's now get a couple of jumper leads. We'll hook the speaker up, and over here from my bigger power supply on the other end of the bench, unfortunately I can only go to what have we got, 74 volts or 73 volts or whatever. So that's our HT. That's the best I can do at the moment. So we'll find out where to go on here with these fellas. And yeah, boy, these leads, they're solid as a rock. Okay, so that will be the negative of this one, goes to the positive, negative, back in here. So, okay, we'll go to the negative of this one, to the positive of this fella. And I think we need a little bit better wiring here too. That's not looking real good. Okay, now I'll grab my leads, put them on, hook her up, and watch the smoke. Rightio guys, I've got the meter hooked up across the battery as well, so that's our HT that we're looking at, which will be 70 odd volts. This thing will still fire up on 70. Actually, well, these things will run fine on 67.5. So yeah, I'll now hook up our B plus supply. It's not turned on at the moment. Okay. Okay, now we've got half a volt there now. Okay, well, here we go, guys. This is the big moment. I've got the volume control about halfway up, so just excuse my audio too. It's a little bit loud at the moment. I'll have to quieten down a bit because this microphone's playing up. Righto, here we go. 3, 2, 1, on. 73.4. I don't hear any audio. Okay, well, least it's nothing happening. Nothing drastic's happened. Okay. So we've got positive and we've got negative. Okay, that's all hooked up okay. What have we got in here? Volume. Nothing. No volume. Okay, got any audio? Let's see here. Absolutely nothing. Nothing whatsoever. Right. Okay, first thing to check, output transformer, which is right in here. So I will take my meter lead off here, and our supply is 73, and to the 3V4 is 2 volts. Guys, I'm pretty sure we've got a dead audio transformer. Okay, pretty certain. It's reading, yeah, 2 volts. Okay, shut him off. Let's do another check. And it'll probably be one of these waxies that's caused the 3V4 to overconduct and burn the transformer out. I would say, okay, what are we looking for here? Take these off, take this off. I'll get a bit better spear on this side, like that. We'll put this on ohms, across our transformer. And yeah, 1.5 meg. Yeah, that's a little bit high, isn't it? So, output transformer. Let's get it out. Let's have a look. Not much use in going any further yet. Right, guys. We're just going to remove the transformer, which is this couple here, the red and the blue. Not making a lot of sense here. Now, pin 1 and 7 are joined together because that's our our center tap with the filament. Pin 2. Now, it says pin 2 and pin 6 are joined together. Well, they're not. Anyway, pin 2 is this fella, which is a 004 cap to ground. Now, if we look at our circuit, we've got, okay, pin 2 here. That number 7 there is a 004 and he's to ground. So that's more or less our blue of the transformer. No, this is our plus. I'm on the wrong one here. That switch is for your filament. I'm being an absolute idiot here. That's for the filament. This switch here, this side, this pole, is for our HT. Sorry. So our HT, that's the negative 6.5 up to the tube. And the other side, the positive, is, yes, this rail. So that's the red, which goes to pin 4. Now, this is number 1, number 2. It goes to number 3. Nothing's been connected to 4. Now, I think this is a different circuit. This is a 3Q4. I'm just going to have a look at a 3V4 or a circuit with a 3V4 in it and work out, well, what goes where with this transformer. I don't think it's been put in the wrong spot. I think it's that circuit's slightly different. Okay, I'll be back shortly. Oh, and by the way, this transformer has been changed. It's not the original transformer. There's new soldering here and here and new soldering here. So, yeah, it's got to come out Anyway, I'm just making sure of things before I remove it. Okay, so I've downloaded some information here just off the net on a typical 3V4 circuit. Now, as you can see, number 2 is the plate, so it obviously comes through the transformer to number 2. A 10k loading on a 3V4, and 90 volts goes to 3 and the transformer. So to the control grid, or G2, so number 3 is tied in with the transformer, and number 2 is the separate one from the transformer. And that's what we've got here. So number 2 is there. This must be our B plus. I haven't traced it all back. I just thought I'd grab a circuit first. But our B plus there makes sense. On pin 2, this goes up here through a 1 meg resistor. Now, I know this circuit's not exactly the same, but if we have a look here, there's our B plus there, and it comes in here, and this says number 4. Well, it's not. On a 3Q4 it may be, but we're number 2 here. So that was just a little bit of the confusion I had there as to what goes where. And yeah, this that resistor, I'm not sure what resistor. This one here, I think, 25, I think is a 1 meg up to here. If we check on our circuit, I'm sort of all over the place here. 24, 25 is a half meg actually. 24 is a 1 meg, which is this one here, 24, which actually goes to the input grid, or G1 of our 3V4. And yeah, I'm not real sure what's the next one, a 1S5. So yeah, but anyway, I'm thinking out loud here, guys. Sorry, I'm leading you astray. This is correct. So let's undo this. That's your B plus there. And obviously, if we trace that back somewhere, it will go to our B plus, which is down here, across here to our switch. Okay, so there's the switch. It also goes up here, somewhere up here, and across to here. So yeah, okay, let's get it out. Enough of the talking. Sorry guys, I'm just making sure of all this before I take the transformer out. But that is correct. And obviously that's not the exact circuit of this radio. So it's a little bit of hit and miss with the circuit for this fella. There we go. And we'll take our speaker leads off here. Neither of these leads are grounded, so there's no polarity, and hence if we get them the wrong way around, possibly no squealing, unless one of the voice coil wires is grounded, which I don't think that's the case. Now, another thing that doesn't look quite normal is this tag strip, which I'll take out now, with a loose screw on it. I don't think that's very normal. Let's see here. Bit warm. Yeah. Yep, that's certainly not normal nor original. Bit of a shame. Okay. We've got a screw, one screw over this end holding the transformer in. Okay, which is not normal again. Okay, there we go. There's our transformer. Screw out. And there. Okay, so that's obviously where that goes. This shield does look like it's, well, part of the radio, but I'm starting to wonder. Yeah, I don't know whether those pop rivets, well, they're not pop rivets, they're just ordinary rivets, are normal, that keeps this shield on. I'm guessing it probably is. Yeah. Anyway, there's the situation we've got there. The transformer was in here. Is this the main transformer, the original transformer? I would not think so. It's a GCL 58. That is not original for this radio. Okay, he's out. Let's see what he measures. That fella on. What's he measure? Open circuit. Right. Okay. We've got to find another transformer. Now, in the package, you probably saw me unpacking this radio. There was another transformer from Carl, and it was an output transformer. So I will have a look at it, and hopefully in around 10,000 ohm primary. Also, have another look at this. Yeah, this may be close to the circuit, but I mean, it's different valves. It's harder to read, but yeah, no, that's certainly not the same. Okay, let's find a transformer and hook it up temporarily and see whether this is going to fire up then. Okay, well, test number 2. I've got the speaker hooked up. A temporary transformer just soldered where the old one was. He's right sitting there, and we're just monitoring our HT. Nothing is turned on at the moment. Okay, let's put our filaments on. And 1.5, yeah, everything's normal. Okay, here we go. And it's drawing 260 mil, which is pretty well right. Okay, so here we go. Ready for the HT? And 3, 2, 1, here we go. 73 volts. Okay. I still don't hear any audio. Let's have a listen. Ah, I do hear audio. Guys, I think, okay. I can hear something. Let's have a listen. Yeah. We've got audio. We've got audio here. Okay. Let's see, can we tune anything? Where are we? Oh, and she springs to life. And can I pick up anything? Yes, I can. Where's the... Okay, that's our ABC at 5:49. And that's our local station. And there's our aerial coil there. So as soon as we touch it, and I tell you what, that speaker sounds $1 million. And we better not play that for too long, I guess. Might make YouTube a bit cranky, but yeah, the bass response, everything of that, wow, and it's not in anything. Yeah, no, that sounds really, really nice. We're away, guys. And I suppose we can go through and check some voltages and so forth, but really, it's a full restoration. All the waxies are going anyway. This little fella here, little electro, I don't know what he'd be like. Probably not very good. Now, down here, we've got a switch. So one of them, I don't know, doesn't sound any different. Only one doesn't go very loud. I think that's the battery minimalizer. And this one goes a lot louder. Yeah. Okay. And we'll switch him over. Oh, gosh, I don't know. There's not much difference. But anyway, the transformer's working. Now, impedance-wise, I've got no idea what this is. So, looks very similar to the one that came out. But anyway, the thing we've got to do is try and fit the thing in, or fit it on the back of the speaker, or somehow. I don't know how this is going to fit in. 73.5. Now, I'm pretty sure this thing will still operate okay on 67. I'll take the voltage back. And yeah, she drops off a bit. There's 60 volts. And that's still running fine. So, yeah. And 70 volts, 73s there. Gets a little bit louder. And obviously, I'm just turning down there a little bit so that we don't get a strike. And I'd say at 90 volts, this thing would pump. That speaker, wow, that sounds $1 million. Righto, guys. Next thing is I'll take the speaker off the plate and let's inspect it more to make sure that there's nothing else to do with it. Capacitors, I'm thinking. Next, clean the switches. Yeah, well, yeah, sorry about all the ums. I'm just thinking there. And no dial cord with this one. It's a bit of a loss, isn't it? Yeah, obviously I'm not too disappointed. So, yeah, let's get some caps done. When I'm doing the caps, I'm not going to show you every one. You all know the caps, where they are. We'll mark them off on the circuit diagram if I can find them on the diagram. It's mostly the same, just that output stage is a little bit different. Now, guys, just before I decided to turn everything off and go to the next step, I thought I'd check our current draw. It's 12 milliamps on the HT, and we're drawing 260 on the 1.5. Okay, so there's our current draw. If we turn it up and
still rolls in.
Yeah,
Beautiful, wouldn't it? Great music.
11, 12 milliamps. I'm happy with that as far as current draw, but that's what she is. Can I do a range on this? And this got got to go back to the other old meter to give myself a more accurate reading. Let's grab it. Okay, there she is. My old faithful. Had this since I was 16. Incredible, isn't it? So, milliamps in here. Here's common. There we go. There's exactly what we're drawing. And if we turn them up,
44% off. Promo in store now. Unbeatable. T's and C's apply. The Women's National.
And really doesn't get much above. There you go, 11 milliamps, and that's spot on. Strange how we've got to go back to these old meters. Next thing I'll have the old Avo back here on the bench, I think. Well, guys, part the way through, I thought we'd have a progress. Those are the caps and resistors that we've done so far. Every resistor I've checked is out of spec. So the resistors are going as well as the caps. So as you can see, we've sort of started up this side and working our way along. So now we've got this bit to go here. So there you go. That's our update report. We'll get these changed, check these resistors, and see how we go there. Okay, the next update on this. Finished all the caps. The resistors are done. Everything's done. Well, hope it works. I'll just bring you down a bit there. Okay, now I've put 2 cables on here to replace the old battery terminal, which we, of course, won't be using one of these at the moment. So I've taken out this old crunchy wire and just put in some red and black wire into the corner here, which goes over to the positive of the filaments and up here to the negative of the filaments, which it's not ground, but we're switching ground. So it goes to the power switch. So that's what's done there so far. Now on top, we had this arrangement of, was a terminal block here, which was broken, and this one here, which was okay. And this is where our 90 volts come in. So what I'm going to do, we've got positive and negative of the 90 volts across here. Now, I don't know how we're going to run this at the moment, but it will be from 60 to 90, whatever. We might have to run this on 67 volts yet. We'll just see. But it'll be those 2 wires. So they're all hard, crunchy. So I'm going to replace them with some blue and black, brown and blue cable for the high voltage, brown being positive and blue being negative. Now they will go to here, to the terminal block, and then out to whatever we have, an external supply. It might be 9 volt batteries in series. I don't know what we're going to use yet. Hopefully a little inverter would be good, but we'll see. It just depends on, the time involved and everything with that. Okay, so that's the next call there, is to just get rid of this old crunchy wire and put new wire in. Clean this up. The bottom has been cleaned. The top hasn't been cleaned, nor has the front had much done to it yet. But anyway, that's it. We also have to lubricate up the tuning gang. It's still fairly tight. Maybe this shaft is tight as well. Clean the contacts of the on-off switch. 2 positions there, and it current limits the feed, the negative feed to your filaments of your tubes, those 2 resistors. So one is a very low resistance, I think it's 150 ohms or something, and the other one is 260 ohms. Now that would reduce your current consumption on your on your A battery, which is your 1.5. So it would last a bit longer, obviously, on economy mode versus versus normal mode. The current consumption, of course, the heavier the current consumption, the more performance you get out of the radio and the better she'll sound. Okay, so I'll start here. Okay, now we've got our wires in. As you can see, terminals there. This is our HT line, and our filament line goes underneath, which I showed you. So they're sort of coming out in separate places, but these will have a plug socket on them to the battery, so that, or to whatever power supply we put in here, so that you can quite easily distinguish between them. Now, all looking a bit grubby in there compared to the bottom. Okay, so I think it's time to clean up the top here. Once I give this a bit of a clean, I'll put the valves in, and oh boy, then we check to see if it still works. Is this going to fire up after I've done all the caps, all the resistors? I don't think I've made any mistakes, but you never know. You never know with this stuff. Okay, we'll go and clean him up. Be back. Okay, she's all cleaned up. That looks a bit nicer inside. Looking quite good. Round the front, yeah, still looks a bit ordinary here. We've cleaned the shafts. Now it's going to put a drop of oil on the bearings of the... I better put my microphone on so you can hear me. One of these days, I've got to get a wireless microphone, haven't I? That's the go these days. I see that DJI have got a very nice little wireless mic out, mini mic, and it looks quite impressive. So I might have to look into one of those, I think. Okay, we put a dab of oil on that end, a very quick dab of oil. We put a dab of oil on that end and give him a turn around, and that's certainly making a bit of difference. Okay, so that's him. This fella, I don't know. I might put a little bit of WD-40 just on the end of him. I'm just getting up and getting my gear here. Okay, so where do we go here? Just in the top, I guess. Oh, gee, too much, Baz. Okay, now that's fairly free. The dial's running nicely there. It'd want to after all that WD-40 I put in there. Right, that's good. Bit of a shabby old needle. Don't know what we're going to do here yet. I don't know the original colour of this. Possibly a white would probably look good on the type of dial it is. A white or a yellow. But yeah, I don't know what it was at all. The thing that I would like you to experience with me is the turning on of this. After I've done all these caps and resistors, is it going to work? I mean, I certainly haven't tried it. It's this is real time, so it'll be interesting. I was going to put the valves in, which I've got written here, but in case you want to know where the valves go. Pretty ordinary drawing, but anyway, that's it. Something I've I forgot this. The output transformer. Where are we going to put it? Now, the other one was mounted up here somehow. There is room here. I will probably put it across a bit and probably on an angle so he fits in there nice. Depending on the clearance we've got between the speaker, both at the top and at the side of it. So we'll have to get the speaker and just see where it fits in here, what it's going to be like. Is there enough clearance here? I'd like to put it on a couple of spaces there. It doesn't have to be very high, but certainly nothing that goes down and crushes the cables underneath it. Now our 3V4 output valve is this one here. So with our primary cables right beside it, that would be perfect there. Okay, yeah. As I said, this is real time. I'm not recording this and then fixing things up and make it look all honky dory. Okay, let's get I'll check the speaker and we'll mount this up. Now I've mounted the transformer. I'm sure this will meet with Carl's approval, the owner of the radio. That's our speaker leads, by the way. Mounted him in here. He's sitting on 2 standoffs. You'll probably see there. Okay, and underneath, well, quite unobstructive, unobtrusive. There's a screw there and a screw up in there. I brought the cables, the primary cables, out through the bottom so that they're not up here in the road anywhere, and to the main HT, which is that fella there. And I'll just make sure he's away from everything, which he is. Yeah, there's no problems there. And to the plate, which is pin 2 of the 3V4. Okay, so that's our main transformer leads. All right. What now? Maybe time for the valves and hook up a speaker and hook up some power and see what happens, eh? Okay. Now, according to my diagram, a 1T4 is up the front there as the RF amp. Okay. The next one we've got is a 1R5. That's that fella there. Okay. Another 1T4 as our IF amp, intermediate frequency amplifier. That's in there. Okay. The next one, 1S5, which is our detector. So 1S5, and that's him. And he goes in there. Okay. And the only one left is a 3V4. That's him. And we know all these valves are working because the radio is working. So unless something's happened with handling the valves, which I doubt very much, we're almost ready, really, to connect some power. Turn him around this way. We'll hook up our external speaker on this at the moment, just to make it a bit easier as to where it is. And yeah, there's our, we'll turn our power supply on, 1.5 volts at 260 mil. Now, we're going to try this once again and see if we've got any shorts. Then we'll put the HT on. I'll grab some cables. And we should see in around 220, 230 once this starts up. Let's have a look. 260. And that's spot on. If we turn him off, there you go, he's off. And this way, 260 mil. Now, I don't know what the difference is between those. Even the switch there may need a little bit of TLC. But there we go. Okay. That's working. Now, our speaker. We've got this external speaker that we're using here. This is a little bit easier hookup to what the first one was. Okay, our speaker's on. Let's get the HT. Our power supply is turned off at the moment. And our brown is our main positive, and the blue is ground. Okay, now I'm turning the power supply on now, and we have no current draw, which is good. Sounds good. Okay, that's turned right down. Let's turn him on. Here we go, guys. This is it. Is it going to work? Okay. And I hear a noise. Oh, yes. Where's our antenna? We'll obviously need some tuning and... Oh, guys.
Complete a short online survey. Celebrating 20 years in the finance business, Finance Music continues to lead the market in lending.
And I will just... we might have to put our aerial loop on because she's... yeah, hang on. I'll try and get rid of some... No, it's not that light. It's not really that one either. Okay. Anyway. Let's have a look. ABC's down here.
Saturday night, anytime on the ABC Listen app and on ABC Radio.
Here on ABC Radio for New South Wales this afternoon. Very
Here we go.
Today.
She's working.
Look, we're also marking in ABC Radio Sydney the
And we'll just...
session Richard Glover, which will happen from 3:30 on ABC Radio Sydney. It will be featuring a final Thank God It's Friday, which will be a big event, and then
just adjusting that trimmer a little bit.
6 o'clock for myself and Richard at that point. So
and we've got a bit of a valve socket there that needs cleaning. This one needs cleaning. He's fine. He's good. He needs a bit of a clean. And I don't know what the difference is. 252 milliamps there, 260 there. So maybe a few milliamps on the lower setting of this. It's sort of a high-low setting. Don't exactly know, but they say it's for battery, battery consumption. So lays off a little bit. Okay. Now we've got the IFs to do. Turn him down. Well, turn him off. We know he's working. Yes. Excellent. I always worry when that comes that time because you guys are watching this live. I'm recording that whole thing. That is really good. So now it's time for the alignment. we'll go through it. This is going to be the next part of the video, the alignment. I will get the speaker ready. We'll probably put the speaker in. I think we can do most of the alignment with the speaker on the front, I think. No, we mightn't be able to get under the IF cans, the IF transformers. So, yeah, we might have to do that. So, probably the next thing, clean the on-off switch, clean the pot, clean the valve sockets, and we'll leave this until the final part of the radio, which will be part 3, and it'll be the alignment. Should be fairly straightforward, so I wanted to do that in a separate video, and we might tidy the dial up. Well, we'll have to have the dial on for the alignment, and part 4 will be the case and seeing what we can do with it. All right. Okay, guys. I hope you're enjoying this little journey with Carl's National Radio, National Australia, made in South Australia, I think. I think it was. But yeah, very unique radio, this one. Alrighty. So that's it, guys. Give us a thumbs up. Please subscribe if it really helps the channel. If you're loving what I do, think about a super chat, and you'll get mentioned right up front there. And yeah, maybe you want people to follow your channel as well. So yeah, drop a super chat to us. Okay, until next time. Bye for now.